Now we're looking at entertainment, we're looking at games, but I think that computer graphics have a lot of very serious purposes as well, some really useful purposes. What are some of the practical uses of computer graphics that affect our lives in important ways?
Well, just about every house that you have seen built recently is designed in a computer. Certainly all buildings are designed in computers. All cars, all airplanes, almost every product, in fact, I think I could actually say every product, your cell phone, your microwave, all designed in a computer now. And it has to be because the computer creates the accurate drawings necessary for manufacturing. So we now can create it in a computer and take that computer information and send it to a device called a 3D printer and create actual products from that without any human ever touching it.
It used to be that you had to draw things with a pencil.
Yeah.
And if you made a mistake, you had to rub it out.
Yeah.
And if you made a lot of mistakes, you have to crumple up the paper and throw it away. So,
Right.
so it sounds like it's increased our productivity a lot. We can get a lot more done because the tools are so powerful.
It's increased productivity, it's increased reliability, it's increased repeatability, and it's increased accuracy. So all vectors have gone up simultaneously to give us better products.
Now I understand in the industrial field, everything is designed with computers nowadays. Everything is visualized. And things like virtual reality and augmented reality play a role there as well.
Yeah, virtual reality is a popular term now that has caught into the mainstream, but virtual reality has been with us for quite some time. It's been used mostly by the military in the past and in some surgical situations for surgical training. So we've had virtual reality soldier training for...
Now virtual reality means that you're immersed in some computer world. To you it looks real, but in fact it's entirely computer generated. The whole scene you're looking at.
You've seen these pictures where people have these massive
helmets,
things. Right.
yeah.
Well, one of the pictures that I should have brought, and I'm sorry I forgot, is the F-35 fighter. The pilot wears a helmet, which is all augmented reality and virtual reality, because they need to have lots of information delivered to them very, very quickly while they're flying this plane around.
So augmented reality as opposed to virtual reality is that you're seeing the real world, but you're seeing computer-generated information on top of it.
That's augmented reality. And,
right.
and the name says it, right? It's augmenting reality for you, whereas virtual is taking you out of the real world and immersing you in a special place, a magic place.
So there must be a lot of military uses for that, as you say. It'd be nice on the battlefield to wear a helmet. Not only can you see the tank in the distance, but you can tell who makes the tank and what side owns it.
Yeah, you can do that. But there's some practical applications too. One of the practical applications I like to talk about is welding. And think about putting this thing on your face. How much different is that than putting a welder's mask on your face, right? So you can, through computer simulation, have a virtual reality representation of welding, and you can put your fingers in there and run the welding tips and learn how to weld without burning yourself or using a lot of material in the process. And you leave, fully trained, knowing how to do that. And I'd point out that there's 20,000 unfilled welder jobs a year in the United States alone.
But if people could get training cheaply and inexpensively without hiring a teacher.
Yeah, exactly.
Now, would this make teachers obsolete? Will this put people out of work?
No, the teachers will still teach you. They'll just use the virtual reality helmet instead of a welder's mask helmet.
I understand there are a lot of medical applications for imaging also. You can get pictures of the inside of the body and see things you couldn't see any other way, enhance the contrast.
And change the colors so that you can see the different parts more clearly. You make the heart red and the lung pink if you wanted to, or green, whatever color you should choose to do it. But that's also used for what is called surgical practice. We are so concerned about making mistakes while doing a surgery that the surgeons have to practice and practice and practice. And especially on delicate things, think about doing a heart transplant on a baby, and this gets done. There's a little tiny heart and little tiny veins that you have to cut, and you can't afford to make a mistake. And so they practice in a computer using virtual reality.
Now, is there an intersection between the computer graphics and robotics, where a robot is doing a lot of the work, like robotic surgery, for example? You, the human, are operating the robot using computer-generated images, close-ups, give you a lot of information. So you're combining the robotic part.
Yeah, in that case, the robot is, and this is kind of an augmented reality also, because in that case, the robot is supplementing your mechanical dexterity. So a robot can make very, very precise and accurate movements and get to precise locations.
Scaling your movements down,
Right.
basically.
Right, and whereas a surgeon, especially if it's a very complicated surgery that's going to take maybe a couple of hours, anybody would get tired. The robot doesn't get tired, and it always makes a perfect cut.
Now, what is the limitation on computer graphics? Is it the processing power of the computer itself? Is that a limitation? Or, because right now graphics are extremely fast. Motion on graphics is very fast. Pretty powerful stuff.
Well, I have a saying that I like to use in moments like this, that in computer graphics, too much is not enough. And what that means is that we have yet to see the limit of computing power that we need for computer graphics. Until we can create a scene in real time of such realism that you absolutely cannot possibly tell if it's real or not, that's when we will have reached the holy grail of computer realism.
Are there any practical applications that we can't do just yet with the capabilities we have, but we expect to be able to do in the next 5 or 10 years or so?
Yeah, the entire industry has been on this exponential curve, which we refer to as Moore's Law. And because of an observation that Gordon Moore made some years ago about the increase in performance of computers and semiconductors. And as a result of that, we can project that law and say, okay, 2, 3, 5 years from now, we should have processors that will have a certain performance capability. If we had such a performance capability, looking backwards, what should we do? We run those types of scenarios every day, trying to figure out where we're going to go next and what we're going to do.
Is there some area that's just crying out to be affected favorably by computer graphics, like the next step, the next thing we expect to be able to accomplish?
Boy, there are so many. There are so many. The design aspects of airplanes, for example. How could we build an airplane that would go twice the speed of sound and safely take people from, say, England to Tokyo in a few hours? Could we do that? Assuming that the engines could be built. Well, wait a minute. Could we build those engines? We can simulate those engines. Yes, we could build them in a computer, and we can test them in a computer, and then we can test the aerodynamics of the airplane in the computer. And so things that we could do is we could increase transportation speed and efficiency by an order of magnitude.
Maybe we could also model atmosphere in a computer, because since you can't see air, it's very hard to know what the currents are. And birds fly by flapping their wings, and I don't think we quite understand how they do that. Because if we did, maybe we could make planes that did the same thing. Maybe there's something about the viscosity of air that we don't understand, which maybe we could model.
It's a possibility, and as for seeing air, there are places where we can see air, and it's not a good thing. But atmospheric modeling and going a step further into weather forecasting, what computers have done for us and computer graphics in the simulations have now made it possible for us to do accurate weather forecasting 7 days out. And it's amazing how accurate it is. Now, truth be told, that was stimulated by the need for the military to be able to predict weather so that they could conduct military operations. Nonetheless, they use enormous supercomputers and computer graphics to do this weather, and now it's prevalent all over. All citizens now have access to this data.